All right, for problems 55 to 62, we're doing derivatives from a table using this table. So basically, when you do derivatives from a table, you want to first take the derivative and then plug in the value that they give you. So here they give us a, and they say a equals f plus 2g. So a prime is going to equal f prime plus twice g prime. And then evaluating this at 3, I'm going to need f prime of 3 plus 2g prime of 3. From there, I read off the table. F prime of 3 is going to be 4, and g prime of 3 is going to be negative 1. So I have 4 plus 2 times negative 1, which is 2, and my answer is B. For the next one, we have to use the product rule. So B prime equals f times g prime plus g times f prime. Then I evaluate at 2. So I need f of 2 times g prime of 2 plus g of 2 times f prime of 2. When I plug in f of 2, I get out 5. G prime of 2, I get out negative 2. G of 2, I get 1. And f prime of 2, I get 3. So I have negative 10 plus 3 is negative 7, and my answer is once again B. For 57, I need the quotient rule. So D prime equals low D high, so G times 0, minus high D low all over G squared. So I end up with just a negative G prime over G squared. When I evaluate that at 1, I get negative G prime of 1 divided by G of 1 all squared. And then I find that G prime of 1 is negative 3, so I have a negative 3 or a positive 3. And G of 1 is 3, and 3 squared is 9, and 3 over 9 is 1/3. So my answer is E. Now I pulled the table of values over to this page to do the next two, and it looks like we've got some chain rule going on here. So for the first one, number 58, to get h prime of x, you are going to need to differentiate the square root function to get 1/2 times f of x and drop a degree to negative 1/2, multiplied by the derivative of what's under the radical, which was f. Now I need to evaluate this at 3. So I'm going to have 1/2 times f of 3 to the negative 1/2 times f prime of 3. F of 3 is going to give me 10. So I have 1/2 times 10 to the negative 1/2 times f prime of 3 is 4. So now when I simplify this, 4 times 2 is 2. It looks like I need 2 divided by the square root of 10, and that is choice D. 59 is another quotient rule problem. So k prime of x equals low D high minus high D low, square the bottom. So for plugging in k prime of 0, I need g of 0 times f prime of 0 minus f of 0 times g prime of 0, all divided by g of 0 squared. So now g of 0, looking at my table, is equal to 5. F prime of 0 is 1, minus f of 0 is 2, g prime of 0 is negative 4, g of 0 is 5, so I'm squaring that. So now I get 5 plus 8 is 13 over 25, and my answer is C. So I brought forward the table again, and we'll do the last 3 problems using the table for derivatives. For number 60, I need m prime of x, which is a chain rule problem. I need f prime of g, g is the inside function, it stays intact, times the derivative of the inside function, so g prime of x. Then I have m prime of 1, which is f prime of g of 1 times g prime of 1. Now, I need f prime of g of 1. G of 1 is 3, and then g prime of 1 is negative 3. So now I need to evaluate f prime of 3, which is 4, and 4 times negative 3 is negative 12, so my answer here is A. For 61, I have another chain rule situation. So p prime equals f prime of x cubed. I differentiated f, leaving x cubed intact, and I multiply by the derivative of x cubed. Now I'm going to evaluate at 1. So p prime of 1 is equal to f prime of 1 times 3. I plugged in 1 for x and 1 for x. So looking at the table, f prime of 1 is 2 and 3 is 3, so the answer is 6, or B. And then we have a derivative of an inverse. So we know that the input into S is 3, and the output into S is something. This is the S function. S is the inverse of F. So on the F function, my input is something and my output is 3. So looking at the table, that means my input was 1. So I now need to find F prime at 1. Looking at the table, that value is 2. So the derivative of S at 3 is equal to the reciprocal of the derivative of F at 1. So the answer is 1/2, or D.